So the question becomes, which is the best measure of center for this data set? How do I know whether I should choose the mean, the median, or the mode? So let's talk about the advantages. First of all, the mean takes into account every single data value in the data set, which is nice. But the problem becomes the mean is easily affected by outliers. The median doesn't really take into effect any of the values of the data set, but instead is determined by the position of all the numbers in order. The median, though, is resistant to outliers. When the mean and the median are really close to one another, it probably means, and I'm saying probably because it doesn't definitely mean this, but it probably means that your data set is symmetric. And we talked about the shapes of data sets last time, and symmetry is one of those things. So let's talk about how we can translate what we found from the mean and the median to talk about the shape of this distribution. Now you might have noticed that I haven't talked about the mode yet. In 99.9999999% of times, the mode is useless. Okay? If I ask you what is the best measure of center for this data set, and you say mode, you're probably wrong. And whatever statistical reason you want to give to back that up, I still think you're wrong. And you know that in this class, there are many correct answers to any problem because, again, this is an art form. This is an exact science. So the calculations, there is one correct answer for the calculations, but how you interpret them, there are many correct answers. So I'm going to highlight my exam scores. I'm going to put a histogram in. We looked at this last time. Here's our histogram for our data. I'm going to make this a little bit smaller. It's not taking up so much room. Again, we want to make sure exam scores that we add our axis labels. If you're using Windows, you have the plus sign here where you can quickly add axis labels to both axes. So this is number of students, and this is exam scores. Now you might look at this and say, well, this is skewed right because most of the data is to the left and the tail is off to the right. I disagree for two reasons. One, we talked about how this first bin on Excel is both including the 45 and the 71. So this bin has more data value range than the other two bins do. Okay? And we also talked about how we can change the number of bins. So now it's still 3 bins. It looks like this is heavily skewed left. Okay? This looks good. I like 5 bins. This looks good. Okay? You can play around with it, but I like 5 bins. And I think this is where we landed last time. And you can see, I like this range because this is kind of like 10 points in each range, but this is skewed right. That's the impression I'm getting. If I were to draw on this, and I did this last time, but if I were to draw in red, we're seeing a tail and then a peak off to the right. So the tail's to the left, and notice the mean here is much smaller than the median. We're on a scale from 0 to 100. My mean is 80.4. My median is 88, almost 90, almost 10 values away. So our mean is here. Our median is here. It's called a skewed left distribution because the mean gets pulled to the left. And so looking at the mean and the median and noticing that the mean is much smaller than the median is another piece of evidence that I can use to say that this is definitely a skewed left distribution. But let's not forget that when I first looked at this data set and I let this auto choose, this did not look skewed left. It looked skewed right. It looked skewed the other way. So that's why it's so important to make sure that not only are you looking at, I don't want to do that. Got it. Okay. I don't want to just trust the first histogram that Excel gives me. Instead, what I did was I found the appropriate number of bins and I just played around with it. Even when I have 3 bins not in auto mode, but in manual mode, which goes from the lowest value to the highest value, I have this skewed right distribution. Okay, I did like 5 bins the most. Okay, and so here's another piece of evidence that tells me that this is skewed left. The mean is smaller than the median, much smaller than the median. Okay.